know this hilarious scene of Charlie Chaplin from the movie Modern Times. What made us laugh so much is the uncontrollable speed of the conveyor belts. Well, in reality, it does not work like that. Thanks to control system, and here's where our story begins. Hi, I'm Srinidhi, third year, Department of Electronics and Communication Engineering, Savita Engineering College, and today I'm here to share my knowledge about control system and conveyor belts. We will see the introduction, block diagram, working principle and applications. Introduction. What is a conveyor belt? A conveyor belt is a widely used industrial mechanism that helps in transporting different materials from one point to another. It is a continuous moving belt driven by pulleys and motors supported by rollers or frames. When control system is integrated with conveyor belts, it is an intelligent mechanism that will help us increase automation, efficiency and safety and make real-time adjustments and meet the real-time requirements. So these are the pictures of conveyor belts. I've also added a picture of escalator and a walkulator. Now we can all have this question that whether escalators and walkulators are also a part of conveyor belts, and the answer is yes. They are specialized types of conveyor belts. They of course have additional features, but the main difference between them is that they transport human from one point to another. But today we'll be specifically talking about industrial conveyor belts. This is the block diagram of conveyor belts. We have sensors in the input and the material movement in the output, and we also have controller, driver unit and conveyor belt itself, and then we also have a feedback from the conveyor belt to the controller. The input device sensor will detect the object presence, weight and speed. The controller, we usually use a PLC, programmable logic controller, or a microcontroller, and then we have the driver unit and the motor, which converts the physical signals into mechanical movement, and then we have the feedback loop, which sends information back to the controller, ensuring closed loop control. Working principle. Firstly, we have detection of material. When an object is placed on the conveyor, sensors such as infrared sensors, proximity sensors, photoelectric sensors senses them, and then the sensor generates an electrical signal and then sends it to the controller, whether it's a PLC or a microcontroller, and then the decision is made based on the programmable logic whether to start, stop or regulate the belt speed. And then we have the motor activation. The controller sends the signals to the motor driver or a variable frequency drive, which adjusts the motor speed and torque. And then we have the material movement, which is our output. And then we have feedback monitoring. Again, the speed sensors or the load cells continuously sends signals to the controller, allowing real-time adjustments. And then we have safety measures. If an overload, jam or emergency stop is detected, system automatically halts and immediately prevents from accidents. These are the applications of conveyor belts. We have manufacturing industry, transport of raw materials, airports, automated baggage handling, and food processing, hygienic movement of packaged food and contamination control. And then we have mining industry, heavy duty conveyors for transporting ores and coal, and logistics and warehousing. And we all know that these are just a few applications. We have lots more when it comes to conveyor belts. Thus, conveyor belt is a prime example of how control system integrated with a mechanical system will reduce the human intervention, maximize the productivity and adaptability across sectors. Thank you.